Welcome to Series Parallel Circuits. My name is Josh Hill and I will be your instructor using resistors as our example. Our objective with these circuits is going to be to try and solve for each one of the unknown values. In this example, I will give you the resistances of each resistor as well as the source voltage. For the purposes of this example, we will be using electron flow. One of the first things we can recognize is we have a series circuit at that very end. Those three resistors are in series, and so what we will do is add them up using our series laws, or resistor 7 plus resistor 8 plus resistor 9 to give us a total resistance of 90 ohms. The next step we take is to redraw the circuit and then recognize what things are in parallel with each other. So our R7 and 9 would be in parallel with our R5. Thus we will use our parallel additive laws, or the inverse formula, to add those resistors in parallel. Once again, we redraw the circuit and recognize that we have three resistors in series: R4, R5, 7 through 9, and R6. And so we will apply our series laws to add those resistors together: R4 plus R5, 7 through 9, plus R6. Once we have completed that, we redraw again and acknowledge that our 4 through 9 is going to be in parallel with R2, and we will use the inverse formula to add those two resistive values together for a total of 15.659 ohms. Our final step in figuring out the total resistance will be once again redrawing and recognizing we have a series circuit. So we will add R1 plus R2, 4 through 9, plus R3 to get a total resistive value of 35.66 ohms. So why did we go through all that work? Well, what we can do now is take our total resistance and our total voltage and find our total current, which is going to be very helpful. With that total current, we can place it into our redrawn circuit of the three series resistors and recognize that that current is going to flow all the way through this series circuit. It will remain unchanged. What we have left to find are the voltages across those three resistors. So then we take our current, we know our resistive values, and we will use them using Ohm's law to find the volt drop across each one of those resistors or group of resistors. Now it's at this point where the majority of you can get to, and you understand what to do up until this point. It's the next step that can get a little bit tricky. At this point, we will redraw the circuit and add our voltages in, and recognize that 4 through 9 was in parallel with 2, and so those voltage values are going to remain the same. Now what we can do is solve for the current that is going through resistor 2 by using our volt drop as well as our resistance. Likewise, we can do the same for 4 through 9. We can take our volt drop and divide it by the resistance, and it will give us our current. It's at this point that we can acknowledge we've got the first three resistors completed, and we can focus on the remainder of the circuit. Now remember, that current that we just found of 0.73 is going to go all the way through that next series circuit. Thus, we can find the volt drops across each resistor or group of resistors as we had done before. Once again, we redraw the circuit, check mark all those ones that we've completed, and then move on to the last part of the circuit that we have yet to solve. We know that we have a voltage of 23.46 and 50 ohms, so we can find our current through R5, and then we can find our current through that last group of resistors of 2.61. Finally, we redraw the circuit again as it was in its inception and solve for the remaining 3 volt drops in the circuit. Afterwards, we put all our volt drops in, so she looks nice and fancy, and we can see that we have solved for each missing value in this series parallel circuit. Thanks for watching, and always remember, it might be tough, but you got this.